So, good morning, everyone. So, today I will be discussing about LDA, that is linear discriminant analysis. In the last class, we have discussed about PCA, that is principal component analysis. It is used to find an axis that maximizes the variance. Means it is used to find a principal component that is a new axis. Instead of two variables, the height and weight, we have found a new axis, that is principal component. Maximize the variation means these are the data points. I have taken an example of a weight and height of a girls and boys. So these are the data points of the data set. So there is a maximum variance between each of the data points, so that we can easily bifurcate the boys and the girls. So similarly, there is an LDA, that is a linear discriminant analysis. It is used to find an dimension reduction technique tool it is uses. So that is, it reduces the dimension, plus it maximizes the component axis for class separation. Means it separates between the two classes. It finds an axis that separates two classes. So for example, let me take a class of a dog and a class of a cat. If there are multiple features with the dog and as well as cat, it will consider the features and separates which belongs to dog and which belongs to cat. So it finds an axis that separates between the two classes. So PC, it performs only dimensional reduction and variation between the data points. Here LDA, it also reduces the number of features, that is dimension reduction. If there are maximum number of features, it reduces the number of features. That means with only few features. Plus it finds an axis that maximizes the separation between the two different classes. Here, so I can say that LDA is used for reducing the dimension and maximize the separability of two different classes. So let me take an example here. So here we got a cancer drug. The drug may work very well for some people, but it may be worse for some people. So here let me take only one gene. So here let me take two genes, gene X and gene Y. These are the data points of the different people. So here let me take only one gene, and if I take only one gene, so these are the data points. I'll project to this variable gene X. So as a project, I'll get like this. Some may work for the drug may work for some people. This dot means it doesn't work for some people. It may work for some people. It may not work for some people. So here, so what happens is there is no separability between the two different classes. We cannot separate between the two different classes here. So if I take two features, that is gene X and gene Y, then it is suppose if I take gene X and gene Y, I can have a separability, that is two groups, which the drug may work for some people, the drug may not work for some people. I can have a separability. My aim is, in case of LDA, to have a dimensional reduction, that is reduce the number of features. Not only class separability, LDA should work for dimensional reduction. So instead of two features, I want only one feature. So I'll generate a new axis, that is what I can say principal component in similarity to PCA. I'll generate two new axes, and these are the data points. So when I project my data points onto this new axis, you can see these are the points of one class, these are the points of one class. So LDA not only reduces the dimension. Instead of gene X and gene Y, I am having only one axis that has information of both gene X and as well as gene Y. So not only reducing the dimension, but also I can separate between the two different classes, an axis which separates between two different classes. So here LDA creates a new axis and it maximizes the distance between the means of one class and means of another class. The aim is to maximize the distance between the means of the two classes, and next is minimize the variation within each category. Within each class, the variation should be what? Less. That is, these are the properties of LDA. LDA, it works for dimension reduction, plus it works for separability between the two different classes, like this. It separates between the two different classes. So PC is an unsupervised learning technique because it doesn't have a label, but LDA has a label. So it is an supervised learning technique, means two different classes. Suppose class dog, class what can I say, cat. So based upon the features, I can separate between the two different classes. So that is the brief properties of LDA. So let us go for multidimensional scaling. So what is multidimensional scaling? So multidimensional scaling is projects the points from high dimensional space to a low dimensional space. So these are the different cells present. Let us take an example. Okay. So different cells, type 1 cell, type 2 cell, type 3 cell, type 4 cells, type 5 cells, different cells may be there. It is a high dimension. My aim is to reduce to low dimension. This is also comes in a dimension reduction technique. Let us take a different example. Here different cells are there. Cell 1, cell 2, cell 3, cell 4, cell 5. And different genes are there. Gene 1, gene 2, gene 3, gene 4. Gene 1, its cell value is 3. Gene 1, its cell 2 value is this one. Cell 3 and cell 4. So we have multi-dimensions, multi-features for every gene, multi-features for every gene, multi-features for every gene. So my aim is to reduce to a low dimension. So what I have to see is whether there is a correlation between the different cells. If there is a correlation, means there is a redundancy. Redundancy means same information is present. If same information is present, then instead of 2 cells, I can have only 1 cell. So if there instead of 5 cells, I can have based upon the similarity, I can have 3 cells or 2 cells. So to find the similarity, here what we are using is, we are using a Euclidean distance. It is used to calculate the distance between the two different cells. So I will find the difference between the two different cells. Difference between cell 1 and cell 2, cell 1 and cell 3, cell 1 and cell 4, cell 1 and cell 5, next cell 2 and cell 3, cell 2 and cell 4. Like this I will find go on finding the difference for all the genes. So here, how to find the difference for all the genes is, so here I am having an Euclidean distance formula, square root of 3 minus 0.25 whole square plus 2.9 minus 0.8 whole square. That is nothing but 3 minus 0.25. Next 2.9 minus 0.8. 2.2 minus 1. 2 minus 1.5. Find the distance. Means add up all this difference, square it, you will get one value. Similarly, find the for every cell to every other cell. For every cell to every other cell, you will find a distance. If the nearest distance, all will be clustered or grouped under one group. So once we have calculated the distance between every pair of cells, multidimensional scaling would reduce them to a 2D graph. So here we have multiple cells, 4 cells or 5 cells or 6 cells may be there. Based upon the similarity, based upon the distance measure, multiple cells may be there. I can reduce it into a 2D. That is, all these cells, maybe cell 1 and cell 4 may be similar. All these cells becomes to one group. Cell 1 and cell 3 may be same. Like this, one more cell, another cell may be same. So instead of multi-dimensional, we can reduce to fewer number of dimensions. Instead of 4 dimension, I have reduced to only what? 2 dimension. In this 2 dimension, I am having which clearly picturizes which are the cells which belongs to the same group or which is having the same information. So that is about multidimensional scaling. Let us go for factor analysis. What is this factor analysis? Factor analysis is the same technique what we have done with LDA and PCA, that is dimension reduction technique. Reduction of set of variables in terms of smaller number of latent variables. Latent variables are nothing but variables where correlation is less. If there is a high correlation, what happens? We are reducing the number of variables. So we have to find the factors such that they are having high variability, less covariance. So latent factors are unobserved variables which are able to explain each and every correlated variables. From the different correlated variables, I will find a new variable, an unobserved variable, a new variable which explains the information of other variables. So that is the same thing. Some information may be measured twice. So what happens factor analysis does is it is used to get rid of redundant information. There are two types of factor analysis. One is exploratory pattern analysis and another is confirmatory factor analysis. What is this exploratory pattern analysis means? So we are finding with a mathematical formula, we are finding a new axis or a new factor which gives information of correlated variables. Confirmative factor analysis means we will see the history. Based upon the history, then we will choose which variable we have to use. So, for example, age and the marks. I have taken last class. I have taken no. I have taken age. I have taken and another was student. What was I have taken? Age and the student class. Yes or no? So, based upon the history, I can choose whether age is reliable or student is reliable. Both I can choose. I can choose one because both of them with this attribute I can predict this attribute. With this attribute I can predict this attribute. So, based upon the history, I will choose one attribute. Here, exploratory pattern analysis means I will use some mathematical formula. Based upon the mathematical formula, I will find a new variable which indirectly explains the information of other correlated variables. This is about the factor analysis. So if I want to give an example, I give an example. Suppose two factors are there, factor 1 and factor 2. So here if I want to explain how well he is in terms of money, if I can say, or the status, independent status, if you want to measure, I can measure in terms of income, occupation, education, house value, number of public parks in the neighborhood. Based upon his means in the nearby house he will be having the parks, how many parks, means his status I can measure. I can measure through factor 1 or factor 2. The factor 1 may be I may analyze through independent analysis. Factor 2 may be independent analysis means I'll be analyzing only income and education on occupation. Factor analysis means how much status he is having based upon his neighborhood buildings. That is based upon his house value, neighbor parks, and neighboring persons how they are. Means this factor I'm analyzing only individual analysis. This is based upon the neighborhood analysis. So the status can be analyzed based upon factor and factor 2. So this is so instead of having multiple factors, I may reduce to only two factors based upon the factor 1, that is individual status and neighborhood status. So this is also one of the example of factor analysis. Thank you.